Hi everyone, my name is Amy and I'm a biomechanical engineer from HasMotion. I'm here to present my research on landmark registration and specifically the effects it has on cyclic and non-cyclic activities. This presentation I gave in the 2024 Canadian Society of Biomechanics. When preparing data and biomechanical waveforms for analysis, it is important that we are properly shaping our data to allow for meaningful analysis and meaningful results. Since we know that how we shape or prepare our data directly affects our results from our analysis, we want to explore whether some of the traditional methods, such as time normalization, is sufficient in eliminating phase variance between trials and participants, or whether there's further shaping that is required. So looking at a general overview of biomechanical analysis, we typically may want to extract certain signals, kinematic or kinetic waveforms, depending on our research question, to then complete an analysis on. For example, we might be wanting to look at ground reaction forces during gait. One of the steps needed to make meaningful comparisons between participants, trials, and just the overall comparisons in the data, we might need to time normalize from a start point to an end point. If we were looking at gait data, this might be from a heel strike to a heel strike. Now with the time normalized data, we can visually see some of the phase variance between, again, the participants and the trials have been standardized, and we can start to look at measures such as the mean and standard deviation. Our question started here by asking ourselves whether this time normalization was sufficient in shaping our data or whether we would have to explore different methods. During this research, we found that often we needed further shaping, specifically landmark registration, to remove phase variance from certain non-cyclic activities. So what is this landmark registration? Landmark registration is a technique used to shape your data and to align waveforms on predefined landmarks or events by applying individual warping functions. If we look at the raw ground reaction forces that are time normalized, we can see that there's still a bit of phase variance at the end of the gait cycles that is affecting the mean and standard deviation at the end to no longer represent individual curves. If we were then to register these curves on intermediate events, such as intermediate toe-offs or heel strikes, we can see that the curves are much more aligned and we can see that general pattern become much more distinct. We can also see that now the mean and standard deviation are much more aligned and are much more representative of the individual shaping. And we can maybe start to look at maybe some more amplitude variance that is happening at the points and in the 40% mark around that might have been missed if we had not registered these traces. To understand the effect landmark registration had on biomechanical waveforms, we looked at the flexion extension of the hip, knee, and ankle across a variety of different activities, split into two categories, cyclic activities and non-cyclic activities. Thanks to two publicly available datasets, we were able to look at the cyclic activities, including treadmill walking, treadmill running, and overground running. For non-cyclic activities, we looked at two different instances of cutting, one that was a full 90-degree cut, and another one that was a snippet of a 45-degree cut. We also looked at counter movement jumps. Each activity was registered on its activity-specific intermediate events, which ranged from 2 intermediate events to 4 intermediate events. Compare how registering can shape the waveforms differently if it's cyclic or non-cyclic. Looking at just the time normalized curves of the knee flexion extension during gait and a counter movement jump, we can see that during the counter movement jump, there is much more variance and we're unable to see less of a clear, distinct pattern than we can in gait. When we then register these curves, we can see an immediate effect that it has on the counter movement jump. And we can now see a much more distinct pattern across all of the trials. We can see though, the gait waveforms did not change that much. And when we start to look at the mean and standard deviation, we can see that the gait really did not have that much an effect. However, looking at the counter movement jump, we can see that there is an obvious difference between the mean and standard deviation of the time normalized signals and the registered signals. We can see that the registered signals, the mean is much more representative of the individual waveforms that we're seeing before. we can see that the standard deviation is much different, is apparent in different areas of the curves, which might mean that we might need to start looking at different areas of where people vary in their jumps. So we evaluated the effect of landmark registration of the joint angles by applying a principal component analysis on the waveforms. Principal component analysis is a way of reducing the dimensionality of a data set into principal components. For data that is normalized to 101 points, we can reduce this dimensionality from 101 to 4 components by still explaining over 95% of the variance within the data. We can look at the variance explained by each principal component by looking at the reconstruction of +1 to -1 standard deviation. Looking at the animation to our right, we can see a green trace which represents the mean of the entire group, and then a blue animated trace, which is the reconstructed principal component across +1 and -1 standard deviation. As we can see the blue trace shift up and down, we can also see it shift left to right, signifying that this principal component explains both amplitude variance as well as phase variance. To measure the effect of the landmark registration using principal component analysis, we looked at the extreme plot for each of the first principal components for the time normalized knee flexion extension and then the registered knee flexion extension. We first looked at specific moments of interest, whether this be local maximum or local minimum, and then found the distance between the +1 and -1 standard deviation. We then compared this magnitude of the distance between the time normalized principal component analysis and the registered principal component analysis. After repeating this process on different joint angles and activities, we can visualize the difference in distances found through principal component analysis on the cyclic and non-cyclic activity. For each activity, we are viewing the distribution of the differences found by comparing the time normalized curves and the registered curves, with larger values indicating larger differences and a bigger effect of the landmark registration. For the cyclic activities, we can see that the treadmill walking and treadmill running had very little difference in distances, signifying that the landmark registration really did not have an impact on the waveforms. However, for the non-cyclic activities, we can see that the difference in distances is much more varied, and we can see that this landmark registration had much more of an effect. Interestingly, if we go back to the cyclic activities, we can see that the overground running did have somewhat of a difference between the time normalized and the landmark registered curves. This might be an indication that something like treadmill walking and running is inherently regulating our gait more and making it more cyclic, and overground running, as we're probably all aware, is much more varied and less regular. So throughout this research, we found that time normalization is sufficient in eliminating phase variance for certain cyclic activities, but on the flip side, landmark registration did help eliminate phase variance in non-cyclic activities. Although these results show that landmark registration can be a promising tool to shape our data for further analysis, we do need to have more investigations that will actually start to look into whether these changes do have a substantial impact on the results that we're getting from these further on analysis. Thank you for your listening, and again, thank you for the 2 publicly available data sets that we used to be able to complete this research.